Okay, I'm doing a video on the practice test. It's called test review, but it's kind of a practice test really because this is a test done in previous years. So in this video, I'm going to do problems. I'll see as far as I go here, and then I'll title it. So, these are both under the square root times. Okay, on number one, notice it says simplify the expression and assume all variables are positive. Because of the assume all variables are positive part, we don't have to put absolute values in our answers. We just have to simplify it. So we know that if you're multiplying two radicals together, you can technically always multiply them together. This is the easy scenario where they're both square roots, so we'll just put them under the same square root. I personally reorder stuff and write them by each other. At this point, you would see if anything pulls out. We know it's a square root, so it's groups of 2. So we have 11 and then 3 times 5. 11 times 3 times 5. Mn. Notice there are no groups of 3, so then you'll multiply it back together. 11 times 5 times 3 is 165, and then we have Mn. That one was pretty easy. Okay, number 2 is simplify the square root of 162, x to the 7th, y to the 8th. So you'd break down 62. This is the same thing as the square root. 162 is 2 times 81, which is 2 times 9 times 9. And then I have x to the 7th, y to the 8th. So then I'm pulling out groups of 2. So I'll pull out 9. I like to rewrite my radical and just kind of go as I go. So if there are, how many groups of 2 are there in x to the 7th? If you have to do it this way, then you can. Pulling out groups of 2. Hopefully you're able to say how many times does 7 divide by 2 evenly? Only 3 times. So we pull out x cubed. Then left would be 1 remaining underneath. And then y to the 8th. How many groups of 2 are there in 8? 4. So that one pulled out perfectly. So that would be your final answer there. Okay. This one, number 3. If you tackle this the wrong way, it's going to be a really rough, hard problem. But if you follow the kind of rules I gave you, this should be actually pretty easy. Well, not necessarily easy, but yeah, at the same time, yes. So remember, the first thing you want to do is put them together. I'm going to change that negative exponent. So I'm going to bring that b to the negative 9 to the bottom. So I have 5a. And now I have a b to the 9th and a b to the positive 9th. I'm going to just go ahead and take that downstairs. Sure, why not? Then I'm going to simplify everything underneath here. So 605 divided by 5. Make sure you keep your fraction line and put things in the correct spot. 605 divided by 5 is 121. a to the 9th and a to the 1st on bottom becomes a to the 8th on top. B to the 9th and b to the 9th on bottom is b to the 18th. From there, we would square root the top. We would square root the bottom. So then the square root of 121 is 11. The square root of 121 is 11. The square root of a to the 8th is a to the 4th. And then the square root of b to the 18th. 18 divides by 2 perfectly, b to the 9th. So that would be your final answer. So if you were to tackle this wrong, it could have been a rough go. So just make sure you put stuff together, simplify everything that can divide out first, split them up, see if any of the square roots simplify, and then from there, you'll look at your final answer. Okay, number 4. See if I can squeeze it in here without going to a new page. 5 square roots, number 4. 5 square roots of 75, x cubed. Then we have a plus square root of 3x. So before you can add radicals together, you need to make sure they're simplified. So we know this is 3 times 25, 5 times 5. So we pull out a 5. And it looks like we have x, so pull out an x. So that is 25. 5 times 5 is 25. A common error is to forget about this 5, but remember that it's there. We pulled out an x. Just making sure I have everything. Left under my square root would be a 3 and an x. Then we have plus square root of 3x. Now don't get tempted to add these together because this is the like term here, which this to be added would have to be an x square root of 3x, and it's not. So this is as far as it can go. Understand if we would have simplified something and had 25x square roots of 3x plus x square roots of 3x, then those are like terms. But look, this one doesn't have an x, like I said. If it was this situation, then we would have 26x square roots of 3x. We just combine like terms. So hopefully we understand that difference here. All right, new page, new page. Okay, number 6. Nope, number 5. Number 5, if we have 3 cube roots of x to the 7th y squared, then plus 2 cube roots of xy squared. Before we add these together, we need to simplify them. So we're pulling out groups of 3. So I'm just going to think advancedly here. Pulling out groups of 3. So if we have a 3 on the how do we write here? So we have a 3 on the outside, and then I'm going to write under my cube root what's left. So pulling out groups of 3. How many groups are there of 3 and 7? So let's think about that. 3 and 3 is 6, so there must be 2 of them. So x squared. And then that would have been 3 and 3, so that would have been 6. So then one of them would be remaining underneath. Oh, why am I writing y? Sorry, guys. I don't know why I'm distracted. One moment. I'm going to pause the video up to there.